Function notation. Function notation is a mathematical notation that shows that one variable depends on another variable and is a useful shorthand for making statements and asking questions. You will learn how to express equations in function notation and how to interpret it. Write the following in function notation. V is equal to 6D plus 10. The V depends on D, so we say that V is a function, wait, I want a thin line, of D. That's better. I'm going to get rid of that. Alright, let's start over. So we say V of D is equal to 6D plus 10. And this is read V of D or V at D. A is equal to 300 minus 20M. So A at M is equal to 300 minus 20M. You notice the right-hand side of the equation doesn't change. It's still the exact same formula. We're simply changing the left from a variable to what's called function notation. H of t is equal to negative 4.9 t squared. Write the following as an equation in two variables. Okay, so this is f of t, so we just say that f is equal to negative 20t. C of d, this is probably, I don't know what C of d is. So C is equal to 24 plus 0.3 d. In all cases, the right-hand side is exactly the same. It's only the left-hand side that changes from a straight variable to h of the variable, the dependent variable, or sorry, the independent variable, which is m, and this is the variable that depends on that. So height as a function of time, let's say. As a function of d. Examples. Using function notation. The cost of a banquet is $200 for the hall rental plus $15 a guest. Write an equation that relates the total cost of the banquet to the number of guests. So as an equation, we just write cost is equal to 200 plus 15n. In function notation, we write the cost as a function of the number of guests is equal to 200 plus 15n. C of n is read as C of n, although sometimes it's read C at n. Note, it does not mean C multiplied by n. Normally if we wrote two things together in math with brackets, we would say multiply. But this case, it's function notation, means that C, the cost, is a function of the number of guests attending. What is the independent variable? The independent variable is the number of guests, and the dependent variable is the cost. Complete the following table of values and use them to sketch the graph. Label the axes. Alright, wish I had a calculator. Ooh, I don't know if I have a calculator on the Mac. 20 plus 15 times 20. No, sorry, 200 plus 15, so that would be 3,200. 15 times 40, 6,200. 15 times 60, 9,200. 15 times 80. Okay, 15 times 100 is 1,500 plus 200. Oh, wait. I should back up, but I'm not going to. Alright, 200 if nobody comes. 15 times 200 is 300, plus 200 is 500. I really need to go get a calculator. 15 times 40 is 600, and that'll be 800. 15 times 60 is 900, that'll be 1100. 15 times 80 is 1200, so that'll be 1400. That's 1500 plus 200 will be 1700, and that's 3200. And here we have our cost. And here we have our, dang, I forgot the number of guests. And we can plot these. I've labeled the axes. So if nobody comes, right, we still have to pay the $200 for the hall. 20 people will be a total of $500. 40 people will be 800. 6, 7, 8. So you gotta watch your scale. 60 people, 1100. 80 people is 1400. 100 people, 1700. And 200 people is 3200. Now at this point, the question should arise, would I join these with a straight line? And the answer would be no, these are discrete, number of guests are discrete. However, we probably would use a straight line just to show us the trend, right? So if we wanted to say, well, what about 140 guests and be able to read the number off the graph, we could do that by drawing, with the understanding, of course, that we know that this really shouldn't be joined by a straight line. Wow, I actually drew an almost straight line. The understanding that this is not continuous data, it really shouldn't have a straight line, but if we did graph every single point, there would be 10 points in here, and it would really look like a line, and this shows us the trend. Okay, so you just need to explain it if you're going to do it. So data discrete or continuous? Discrete. We can only have whole numbers of guests. Right, whole numbers because there could be 0 guests. You should determine the cost for 60 guests is $1,100. This can be expressed as C of 60 equals 1,100. What does C of 80 equals 1,400 mean? It's the cost of 80 guests. So cost of 80 guests. It's a shorthand notation, right? Because we could say, what is the cost for 60 guests? Or we can say C of 60. What is the cost for 80 guests? Or we could say C of 80. What does C of 250 mean? The cost of 250 guests. Sounds like somebody's scoring. Use the equation C of n equals 15n plus 200. So if we want to determine C of 250, everywhere we see an n, we replace it with 250. So I've got the function there, right? Remember math, formula, substitution. Okay, everywhere I see the n, I'm going to put in 250. I need 15 times 250, which will be 2,500, and 1,250 will be 3,750. So 3,950. You have a calculator, you can probably use it, and I think if I'm using the Mac, I don't have a calculator. Use the equation C of n equals to determine C of 70, the cost of 70 guests. In English, that's what this says, the cost of 70 guests. So C of 70 is 15 times 70, right? Wherever you see an n, you're going to replace it with a 70. Plus 200, which is 700, plus 350 is 1050 plus 200, or 1250. And if any of these are wrong, let me know. I'll throw in a little box. How could C70 be determined using the graph of the function? Look along the n-axis or 70 and go up to the graph. And then go across, then across to the c-axis. So let's do that. Oh, I hate this relative. I mean, absolute. Okay, 70 here, right, and over to here, and we've got 1250. So by drawing the line in, so we would go to 70, go up to the graph, and then go across, and see that we had $1,000, $1,100, $1,200, $1,250. How could you use the graph to find out how many guests were by the cost? So find $2,000 on the cost axis, go across to the graph, and then down to the n-axis to get the number of guests. Go back. So 2,000, go across, and then down. And we see that it's around 120 guests. Question 10 can also be asked, what is n if c of n is 2,000? So that's using function notation. Use the equation c of n equals 15n plus 200 to determine n if c of n is equal to 2,600. Okay, math, formula. I have a formula, substitution. Where I see c of n, I'm going to substitute 2,600. It's 15n plus 200. I'm going to solve this. I'm going to subtract 200 from both sides. 2,400 is equal to 15n. So n is equal to 2,400 divided by 15. Yeah, which is... Sorry, gotta do some longhand math here. No calculator handy. It's 990. I think that's 6. I always get that wrong. So 160. Use the graph to answer the question, what is n if c of n is 2,600? Okay, so if the cost is 2,600, going to come across to here, and then down, and we get 160. Okay, so we can get the answer off the graph, we can get the answer from the equation. Example 2. The height of a ball h in meters is given as a function of time, t in seconds, by h of t. The height as a function of time is 100 minus 5t squared. The graph is shown. What does h of 2 equals 80 mean? Well, it means the height at a time of 2 seconds. The height of the ball at a time of 2 seconds is 80 meters. Right, look on the graph here, you can see that at 2 seconds we have 80 meters. Use the equation h of t equals to determine h of 3, determine the height of the ball at a time. So let's write it out. Math, formula. Substitution, the height at a time of 3 seconds, that's why it's sometimes called h at 3, or h of 3, be the cost of a number of guests, the height at 3 seconds. Okay, wherever we put in for t, in this case we put in a 3, we put that in everywhere we see a t. So that's 100 minus 9 squared, or sorry, 9. 3 squared is 9, times 5 is 45. So h of 3 is 55. H of 3, h of 3, we're at the end, let's call that meters. 3, here, 55. Right, go to the 3, up, across, 55. Use the graph to estimate h of 2.5. Here's 2.5. Go to here. And you can see we're just shy of 70. So I'm going to say maybe 68 meters. Use the equation to determine h. Well, here it is. There's the formula. So let's substitute h of 2.5 is equal to 100 minus 5 times 2.5 squared. It's 100 minus 5 times 6.25, which is 100 minus 31.25, I think. 6.255, carry the 2, 10, 12, carry the 31, yeah. And we get there a 5, and then 9 will give us a 7. And then there's got to be an easier way to do this. Well, okay, 7, 5, that makes 32, so 8 there, 68.75. Meters, right? Because that is a, and we'll just assume that carries down. Our answer is the same. Close. No. No. Part D is more accurate. The calculation will be more accurate than reading off of the graph. Reading off the graph may be good enough. Calculation is more accurate. So reading off the graph might be good enough, depends on what you're doing, but the calculation in this case is needed. Use the graph to find t if h of t is 20. So if this is 20, we're coming across to here, and we would say 4 seconds. Right, so we go to 20, we go across to the graph, we then come down and we read 4 seconds. Need units. Remember, that's times, 4 seconds. Estimate the range value, that's the y value, and the domain value, that's the x value. Well, we don't really have x and y, right? This is really the t-axis and the h-axis. So the range value, which is h, when the domain value, which is t, is 3.5. Times 3.5, come up to here. Where are we? Let's say 30, that's 35, let's say 37. I'm going to say 37. Meters, ranges in meters. State the domain value when the range value is 95. Okay, 1 second. 1 second. Graph this function in your calculator using the same window as the graph shown above. Use your graphing calculator to verify the answers in parts B, D, F, G, and H. Like, yay. I gotta pause. Okay, I'm back. I had to go find an emulator for a TI. Graph this function in your calculator using the same window as the graph shown above. Okay, so I gotta figure out what the window in the graph shown above. So we need a window of 0 to 5, or maybe 6. Let's look at this. So let's go 0 to 5 by 1/2, and 0 to 110 by 5s. Okay, so window. Ooh, this looks like the color one. 0 to 5 by 0.5. What's kind of neat about this emulator is that you can see everything happening. You can see the key presses and all of that good stuff. And 0 to 110 by 5s. too fancy for me. I don't know what that stuff is. So y equals, so 100 minus 5x squared. Okay, that wasn't an x. Alright, let me do it on here. 100 minus 5x squared. Ah! I don't have a minus sign. Let's go back. Okay, so I want to go second function, insert, minus. I think we're there. Let's graph it. Okay, we're not there. 100 minus 5x squared. 0 to 5. Oh, y min, negative 10. Wow, what did I do there? 0. 1. Oh, I see what I did. 110 by 5. So x res should always be 1. Okay. Fixed. There we go. Pretty cool, huh? Neat about the emulator is you can actually see, key presses and all that good stuff. Now we're supposed to verify this value on the graph, h of 3. So second function, calc, value, and we want x to equal 3. Enter, and we get a y value of 55. Which is what it should be. Use the graph to estimate h of 2.5, or use the equation to determine h of 2.5. Second, calc, value, x equals 2.5. Enter. And 68.75. So there was our estimate of 68 and our value. If h of t is 20, so if the y value is 20, so we have to go to y equals, go down to y2, and for those of you who don't yet have calculators, this 84 plus C silver is pretty cool. Graph that, and what we're looking for is this intersection point, right? We're looking for where these two lines meet. And we can actually see it in here because this is showing us the table of values that it'll happen in 4 seconds. We actually already know it's 4 seconds, but how do we do it? We go second function, calc, into the calculate menu. Second trace takes you to the calc. We want number 5, which is intersect. And what I do is I move my cursor until it's at the intersection point. And the reason is, calculator asks for 3 values. It says, what is your first curve? And you notice it's showing you up here, and you hit enter. What is your second curve? And now it's showing you this graph in color. Cool, color. And it asks you for a guess, but I'm already there. We're really close anyways, right? And we hit enter, and we get the exact value, the intersection. Here it is here, 4. Estimate the range value in the domain is 3.5. So second, calc, value, 3.5, enter, and we get 38.75, and I said 37, so, it's close. State the domain value and the range value when the range value or the y value is, so let's clear this guy out and put in 95. Hit enter. Graph. Watch the graph. So first it's graph 1, it's y1, and then it's y2. And we want the intersection, although we can see it in the table, I think, or we will. It's interesting, that's not up to date. Second, calc, intersect, so number 5. Oh, now we can see the 95. So you see it's going to be at 1 second, but now we just hold that down. Press it a bunch of times, I guess. And then hit enter 3 times, right? First curve, enter. First curve, enter. Second curve, enter. Guess. Guess. And we get x equals 1. So we have done that. What's next? Oops. The graph. Hey, I've got my pen back. Didn't have the pen thing. I'll pick up the pen and it'll probably go away. The graph of y equals g of x is shown. Using the graph, state the value of g. I'm actually on my trackpad now. Of g of -3. Okay. So what we do, we want to know what is the value of g of x, right? What is the value of g of -3? So when x is -3, we have a value of 9. See, I get a pointer. State the value of g of -1. When x is -1, the value of g is 3. State the values of x such that g of x, when is g of x equal to 5? Okay, here, -2, and here, +1. So x equals -2, x equals 1. State the values of x such that g of x is equal to 9. So you go to 9, and you go along 9, and you see -3 and +2. State the range value when the domain value is 0. Domain value is x. When x is 0, the range value is y. Y is 3. Would you be able to state the exact value for g of 2.1? Well, here's kind of 2.1 and that, and I would say not exactly. No, because it's not on an intersection, right? We can state it when it's right there, right on an intersection, 0.15. Otherwise, we can't. So, no, not a grid intersection. Right, we have to estimate. Where 2.1 is. Stubborn. I go back, then I get the pen. Go forward. A golf ball is hit, and its path is defined by h of d is -0.004 d squared plus 0.4 d, where h is the height in meters and d is the horizontal distance in meters. So we have a couple of distances. One is a horizontal, that's this distance. The other one is height, that's up, down. Use your graphing calculator to graph this function and write your window in proper format. Okay, let's get the graphing calculator out. Where am I going to put it? I'm going to drag it down here a bit. So let's go to y equals. Let's clear out what we have. Clear. Go back here and let's type in the value. -0.004. Darn, look at that. 0, I'll start clicking, 4 x squared plus 0.4 x. So there's my graph. Now, I think if I hit enter, we need to get a window for this, right? So let's go to window. So we could say, well, the horizontal distance will go from 0 to wherever this thing lands. Now, I don't know, how far is it reasonable to hit a golf ball? Let's say we hit 100 meters. And we'll go by tens. And then how high will this go? Wow, this doesn't want to take impulse. 0. I'm going to go with 30, and I'm just guessing. And we'll go with the y scale of 5, and we will hit graph and see what we get. Oh, nice. It hits exactly at 100. I went too high. So we can readjust our window to say your y max, let's go with 15. Okay, and then hit graph. And there we go, nicer graph, right? If you fill more of the window, you get a better graph. So write your window in proper format. So window is an order triple, right? X min, so 0 to 100 by tens. Let's see if stuff disappears. X, 0 to 100 by tens. And Y, we went 0 to what? 15. And you know what? That could be ones, so I'm going to change that to 1. I'll move this around a bit. 1. State the value of h of 40. So that's the height when the domain, or the x value, in this case because we're dealing with x's and y's, so we go second, calc, value, 40. Enter. And the height is 9.6. 9.6. Meters, there's units associated with this. State the value of h of 70. Hang on, let me get back my calculator. Powering down. Come on, where's calculator? H of 70, second, calc, value, 70. And we get 8.4 meters. Let me just move this over a bit. Actually, let me just move this over here. So 8.4. No, that was my bad. I changed it from a pen. Go back to the pen. I want a pen. State the value of d such that h of d is 3.6. Okay, let's go back here. So h of d is y, so we want y to equal 3.6. And graph. And you notice there's actually two values for d. So let's find them. Second, calc, intersect. We need to move. Now, actually, you know what? Here's the thing. Right now, it's on y1. If I hit down arrow, it'll move to y2, the straight line. And it's going to be faster to move along the straight line to the intersection than it is to go around the curve. Not much faster, but it will be faster. Okay, and then when we're on the intersection, enter 1, enter 2, enter 3, and we get an x value of 10. Now, we didn't say when it first reaches that value. So here, I'll show you what will happen if we trace along the curve. You know, so we got to go all the way around the curve to get back down. I'm going to takes a lot of work. Okay, what do we say the first value was 10? And the second time it reaches, it's 90. So D equals 10, or D is equal to 90. State the value of D, and I don't know, maybe this should say values, or maybe it should say state the value of D when the ball first reaches a height of 3.6. So remember, that's going to happen once on the way up and then again on the way down. State the value of D such that h of D is equal to 7. Hang on, I'm going to get my calculator back. Okay, so we're going to y equals, going down to y2. We'll clear that, replace it with a 7. Graph. Second, oops, gotta wait for it to finish graphing. Second, calc. Number 5 is intersect. Move to the point. This won't take as long this time because it's higher up. 1, 2, 3. And we've got 22.6. Okay, so let's call that 22.6. And, alright, you know, I'm going to y2 this time. So this way I can go across the straight line. So what did we say? I already forgot. 7.6 and 22.4? No, 77.4. 7.6 and 77.4. I'm doing that on the touchpad, which I shouldn't be. D equals 7.6 and D equals 77.4. Next up, if f of x equals 3x squared minus 7x plus 2, then algebraically determine. Okay, so no calculator, f of 2. Well, you've got the formula there, right? So when we write f of 2, we rewrite the formula, but everywhere we see x, we replace it with a 2. So that's 3, that 2 squared is 4, so that's 12 minus 14 plus 2, so 12 plus 2 is 14, minus 14 is 0. F of negative 4 equals 3 times negative 4 squared minus 7 times negative 4 plus 2. Negative 4 squared is positive 16, so that's 48. Minus negative 28 is plus 28 plus 2, so that's 30, 78. If f of x equals 5x plus 6, then algebraically determine f of negative 4, right? So that's 5 times. You have a formula, right? All we're doing is just basically substituting. Plus 6 is negative 20 plus 6 is negative 14. X, so that f of x equals, no, so in this case I'm going to rewrite the whole formula. And then I'm going to substitute. Where I see f of x, I substitute 85. I subtract 6 from both sides, so that's 79 is equal to 5x, and I divide 79 by 5. And since that's not a multiple of 5 and 5 is prime, then the answer is 79 over 5, unless they ask us to round it. X, so that f of x, again, write the formula, right? Secret to math, formula, substitution, answer. There's our formula. Substitute negative 34 is 5x plus 6. Subtract 6. Negative 40 is 5x. X is negative 8. Is there more? Let me just put the pen down. There is not more. That is good. So I'm running out of time. So that's our thing. It's a long-ish lesson, but very important one, and showing you how to use the calculator as well. Make sure that you have a TI 83, 84, 84 plus, or 84 plus color, which is really kind of cool calculator-wise stuff.